You know, the car you drive every day, it's an absolute marvel of hidden engineering. Today, we're going to pull back the curtain on one of its smartest secrets, the technology that actually makes your car both lighter and stronger at the same time. We are talking about Tailor welded blanks.
It really sounds like a paradox, doesn't it? I mean, how do you make a car lighter so it gets better gas mileage, but also make it stronger so it can protect you in a crash? That's the fundamental puzzle that automotive engineers are trying to solve every single day.
So here's what we're going to cover. First, we'll dig into the car maker's big dilemma. Then we'll look at the solution, perfectly tailored metal. We'll see how it's made, run through all the benefits, see how they test it, and then take a peek into the future. Okay, so what is this core dilemma for every car company out there? Well, it all comes down to trying to balance three completely competing pressures.
It's what engineers call the design trilemma. You've got regulations demanding lighter cars for better fuel efficiency. At the exact same time, safety standards require stronger, safer vehicles. And of course, all of this has to be affordable. I mean, you can't just build a car out of super expensive, exotic materials and expect anyone to buy it, right? So that's the challenge.
The solution that engineers came up with is just so elegant and so efficient. And what's wild is that it's hiding in plain sight in millions of cars on the road right now.
The answer is the Tailor welded blank, or TWB for short. Now, the key thing to understand here is the timing. This isn't about welding finished car parts together. No. This is about creating a custom sheet of metal first. You take different pieces, some thick, some thin, maybe one's even specially coated, and you weld them all together into one single blank. Then, and only then, do you take that custom blank and stamp it into the final part.
And there's this brilliant analogy from the source material that just captures this idea perfectly. You know, you don't make an entire suit out of heavy, thick wool, right? You use different fabrics for different needs. Well, the exact same principle applies here. You're literally tailoring the metal itself to perfectly fit the job it needs to do. So it all boils down to this one crucial point: engineering efficiency. You put the thick, high-strength steel where you need it for crash protection, and you use thinner, lighter steel in areas that don't face the same kind of stress. No waste in material, no unnecessary weight. Just the right material in the right place.
Okay, so how is this actually done? I mean, how do you weld two different sheets of steel together so perfectly that they can then be stamped into some complex shape without just falling apart?
Well, one common method is something called gas tungsten arc welding. Basically, it uses a super precise electrical arc to generate this intense heat, and that heat fuses the two pieces of metal together with an incredibly clean and really strong bond.
Now, in big industrial settings, the technology has really evolved. While older methods like mash seam welding work, they create a much wider joint. Modern laser welding, on the other hand, is a total game changer. It produces a weld that's much narrower, cleaner, and stronger, which is absolutely perfect for the high-speed, automated world of car manufacturing.
Now that we know what they are and how they're made, what are the real-world benefits of doing all this? Why go through all the trouble?
Oh, the advantages are huge. For starters, by combining multiple pieces into one smart component, you get part integration, which just makes assembly way simpler. And of course, that leads to mass reduction for better fuel economy and improved material yield, which means less waste. But critically, all of this results in better structural integrity and significant cost reductions. It's a win across the board.
And look, this isn't some niche, futuristic tech we're talking about. These things are in the most critical structural parts of your car, right now. The inner panel of your door, the rails in the engine bay, the pillars right next to your head, and the frame underneath you, all of them are likely using this incredibly smart, tailored approach.
But how do engineers know that these custom welds will actually hold up in a real-world crash? Well, the answer is through some seriously rigorous testing. It all starts with a test specimen, something just like this one. In this case, researchers have welded stainless steel to mild steel, creating a basic, tailored blank that's ready to be put under some serious stress. Then that specimen gets locked into this beast of a machine called a universal testing machine. And as the name suggests, its job is pretty simple, really. Apply a ton of force. It's going to pull on both ends of our specimen, and it'll precisely measure exactly how much force the material, and especially that weld, can take before it finally fails. And this shot, wow, it brilliantly illustrates the result. You can literally see how the metal has stretched and deformed before it broke. This shows engineers exactly how much it can bend before it fails. But here's the real goal. What you want to see is the failure happening in the base metal, not in the weld itself.
Because if that happens, it proves the joint is actually stronger than the materials it's connecting. How cool is that? So all that pulling and stretching generates hard data, like what we see here. This chart compares the impact strength, basically the toughness, of two different welding methods. It's showing that an arc weld can absorb a lot more energy before it fractures, compared to a TIG weld in this particular test. Now, this doesn't mean one is just plain better than the other. It's all about giving engineers the data they need to select the perfect process for each specific part of the car.
So, this technology is already incredibly advanced, but it's definitely not standing still. Where is it all headed next?
Yeah, the next big frontier is aluminum. Creating aluminum-tailored blanks could lead to even bigger weight savings, which is absolutely crucial, especially for electric vehicles. But it comes with new challenges. Welding aluminum to steel is notoriously difficult. It can create really brittle joints. And as always, there's that classic engineering trade-off. You've got the higher cost of these advanced materials versus the huge gains in safety and efficiency you get for the consumer.
So, we've seen how this idea of tailoring materials has completely revolutionized car design. It really makes you wonder, if we can tailor a piece of metal for a car door, where else could this incredible idea of putting exactly the right material in exactly the right place change the world around us? From aerospace to architecture, the future, it seems, is tailored.